actually, hang on for one moment. All right. Apologies. I just noticed in the YouTube chat that it looks like the stream did not start. So I've got that going now. So for folks that may need to go back and rewind a bit, I apologize. But so there we go. Technical difficulties. Apologize. So technical difficulties. All right. So now it looks like we're actually live. Alan, I apologize for that. So that actually
no problem.
Gives us a few less minutes, but that's all right. So I want to just reintroduce myself then. I'm David. I'm a developer advocate here at Balena. Balena is an IoT fleet management platform that allows folks to very easily control large sets of devices such as Raspberry Pis, NVIDIA Jetson Nanos, or other types of enterprise-grade IoT hardware. I'm joined by Alan, one of our hardware hackers on the team. Alan is actually based, I believe, outside of Philadelphia, and I'm coming to you live from Phoenix. So for those of us just getting joined up, there we go. I see someone is actually from Germany as well. Matthew's online as well. Looks like we've got quite a crew. Awesome. Thanks, guys, for joining. So we're going to go over our LED alerter project. Our LED alerter project is something that we put together a little bit after, I guess you could say, the start of the current situation where, you know, more and more folks are working from home and, you know, there's interruptions, kids are coming in while you're on a video call, and you kind of want to give people an indication that, hey, I cannot be interrupted right now. Or, yeah, you know, I'm reading email, I'm doing some research, no problem, come and ask me a question. I, for example, have small children, so this project works great. You know, my 6-year-old can just very easily see, oh, he's available, or no, he's not available. So, Alan, if you want to give just a real quick introduction, looking at the clock in the name of time, we'll move pretty quick.
Yeah, sure, David. Yeah, like you said, it's a way to indicate to others in your vicinity whether you're available or not. And there we go. We're already beeping here.
Oh boy.
So we'll get to that part as far as how that works, how you control this. But basically, what we wanted, and there are many ways that this could be accomplished. Obviously, you're really just controlling 3 LEDs remotely, and that can be implemented many different ways, but we wanted something that was simple and very portable because there are other projects where you can, sorry, I'll try not to get distracted by that. But, you know, there are other projects, you know, good projects that you can hang on the wall or hang on your door that do kind of the same thing. And this one, we want it to be completely portable. All this needs is a power connection. And then it has inside here a Raspberry Pi that's connected via Wi-Fi to the internet, of course. And then what you have is a client that is the web page that's actually served out of here. This being like the server, the web page being a client. And using that client, you can control the lights and therefore let people know about your status. And I believe that we have published the URL. The Balena Cloud Platform allows you to have a public URL for this. That's optional. It could be private if you want. I've made this one public. So literally anyone in the world can change the status of this. And that just goes back to our fleet aspect where you know, you're not limited to having this in one room and the web page in being used in another room. They could be in other cities, even if you wanted to, which shows kind of one of the industrial applications you could actually use this for. But that's not what we're going to concentrate here today.
Yeah. So that giant LED tower, now I don't have one of those laying around. Where did you get that thing? How do you come across something like that?
Yeah, this is available on a number of sites, including like Amazon, AliExpress, even Adafruit has a version of this.
Oh, cool.
And yeah, It's mainly meant for industrial equipment. Yeah, you may see this on equipment that's about to start up, and then it beeps and the light changes to warn you that a piece of equipment is starting. But it works very well for our purposes as a very big alerter.
All right. Now, if I don't want to go, you know, try to pull one off of some heavy machinery somewhere, is there an easier way? I think I recall you had a smaller version that you had built just from breadboard and some LEDs, correct?
Yeah, this is a kind of a breadboard version right here. And you can see it's a very simple circuit, really, when you do it this way. And this is probably the simplest way you could do it if you don't want to go, get all the parts for this build. On the blog post for this project, we do have the plans for just doing a simple breadboard version. It uses the same web page. There's still a web server hosted on here that you can access either privately or publicly. And then you can change these LEDs with that web page. And you could really just build it like this, probably in 20 minutes, and just sit it on your counter and still have pretty much the same effect, just not quite as visible as this guy.
Yeah, absolutely. Just can't see it from a quarter mile like the larger version. Okay.
Right.
And that is in those instructions on the smaller version are included in the blog post as well. I just dropped the link into the YouTube chat, so anyone can sort of follow along there, whether they want to go with the large scale version or the smaller version. And I believe it's also got, the bill of materials, all the parts that are needed. But essentially, let's talk about that real quick. What would you need in order to replicate that? Obviously, you mentioned a Raspberry Pi. You showed that. You saw some LEDs. Is there anything else I would need from a hardware standpoint?
Yeah, well, like you mentioned, we have various versions of the build. So, from the simplest build, it's always a Raspberry Pi. That's what we use to control this and to host the web page. Really, any version of the Raspberry Pi will work, even down to the Pi Zero. That's what we have in here is a Pi Zero W. We have a really nice matrix grid on the blog post that shows which Raspberry Pi is the best one to use and what features you will or will not have depending on which version of the Pi you have. But whichever one you have lying around will work for it, with varying features. And then of course you need the LEDs and at a minimum, a few resistors to reduce the amount of current running through the LED, so it's compatible with this. If you do want to use an industrial tower, I recommend using a 12-volt version. And in that case, the 12-volt LEDs cannot be run directly from the Raspberry Pi. You'll need something in between to buffer them. And that's where we go with something like this, a relay board.
Okay, a relay board.
Yeah. So the Raspberry Pi can drive these relays, and then the relays can handle the much larger current that's needed to switch on a light of this size and brightness. So, both the voltage and the current for these are different than what you could connect directly to the GPIO pins of a Raspberry Pi. So you would need a little relay board like this. You need one relay for each light and for the buzzer. And if you don't want to use an outboard, they also make a hat like this that you can actually attach right to the Pi itself. So this fits right on the Pi. It has these nice screw terminals. And in that way, no soldering is required. So that was one of the requirements. We wanted to make this more accessible to people. So you can theoretically and actually quite easily build this project without any soldering. And we outline that as well in the blog post.
Okay, yeah. I'm not safe with a soldering iron, so that would be the way I would go. Not good with the soldering. All right, so now you also, I think, have a new toy that you've started to hack on there, a little hardware controller because you're tired of us all buzzing your light from around the world. So what have you been up to that I just got a glimpse of earlier?
Yeah, well, let me show this off here. This is a new device that I've made to accompany the LED alerter. This is obviously optional. So this basically is what I call a hard switch that takes the place of the web page client I would say take the place of, but you can use this alongside of it. So somebody just switched, that was not me, and you'll notice that this button synchronized with the new state of the LED alerter. So if I change this, you'll see the light again. So now it changes. Now, if you go to the web page and also change the state, these buttons will synchronize. So this is for maybe you want to change this from a location where you don't happen to have a web browser or a web page open. So in these LEDs, this light tells you that this box is powered up. And this is a cool LED that tells you that you have a WebSocket link established to this device. So it's just letting you know that, yeah, the device is connected on the other end. And that other end can be thousands of miles away or in the next room, because both of these work on Wi-Fi and they're using public URLs. So they can really connect from anywhere. We also have this button here that allows you to turn the buzzer on and off. So you may not want to annoy people with the buzzer. So this switch allows you to do that as well. So this, again, is really just another version of what the web page does, but a non-software version of it.
That's cool. And what sort of parts does that require? I see some LEDs, those just simple, like, Adafruit type LEDs, or what are those buttons themselves, I guess?
Yeah, these are, I think, 16 millimeter buttons from Adafruit. I don't have another example of them sitting around, but 3 buttons with 3 LEDs. Now the LEDs in here are optional. The minimum you would really need for this is just 3 push buttons. You could do it with that. I went a little fancier because I liked having the lights inside the button synchronized with the current state. And even this buzzer switch is optional, the 2 at the top. So at the minimum, a Raspberry Pi and 3 push buttons, and then you can just get fancier from there. We don't have this one on the website yet, but I'll probably add this to our playground. So people, if they want to extend, this is highly optional, but if you want to try it out, we'll put the plans for that up on our website.
So the last piece I want to talk about, we've been mentioning mostly all the hardware here, but what about the software that is running on this? Do folks need to write a bunch of code to make this happen? Or in that blog post, I took a glance at it and it looks like all of this is automated for the most part, correct?
Yeah, we've done all of the software already, so you really don't have to know any coding, but it's all open source, so the software is listed in a repository if you want to look at it and kind of see how we're doing it. Just really quickly, I don't want to get too technical, but this is using Node.js, and it's also using an Express web server and a few NPM packages for controlling the GPIO pins on the Pi, and it's using a WebSocket client as well. And that's as technical as I'll get, but you don't need to know about any of that to build this, but I just thought there might be people there who would be interested.
But if you go to
so if you go to the blog post, you can look at the repository, but you don't even need to know that, because it's just a matter of uploading the project through your, you sign up for a Balena Cloud account. First 10 devices are free, so you could deploy many of these if you wanted to, and just upload the code that we've provided.
Yep. So essentially, the process would be something like this, then, if I understand correctly from what you've put together there. So you would go and sign up in on the Balena website. You would clone the repository that you just referred to, and then you would push that code to the device through the Balena CLI. And all of that, again, is documented in the blog post, so folks can just literally follow the steps right throughout the process. And then once that occurs, the Raspberry Pi will essentially download all of the software that you have already built and pushed into that GitHub repo all by itself. So it will simply download the containers and begin running the containers, and assuming that the hardware is in fact wired correctly and follow the user followed the steps, There's really no coding required then on their part.
Correct. Yeah, there is no coding, but as I said, it's really easy to modify.
Sure.
And because you're using the Balena Cloud, it's easy to push your changes remotely. You know, that's one of the great benefits is the public URL, and the setup using Balena Cloud is just easier because you don't have to look for the IP address of this thing. You just flash the card with your like Wi-Fi credentials. It stays, you know, private. And then once you insert the card into the Pi here, it will connect to the cloud, and then it's easy to push software and changes, and also, you know, all the great monitoring that you can do. You can even SSH into it. So it just makes a lot of that simpler, and you could really just enjoy the project as is, or if you like to hack and code, you can extend it with a lot of features. Just want to add, I put as a hack feature, I added this kill switch to the buzzer. So even if somebody tries to use the buzzer remotely, this kill switch will override it. And so that's a really good hack to add to this.
Yeah, because I noticed a couple people in the YouTube chat, I think may have stored the URL from previous episodes of our IoT happy hour, which, by the way, I wanted to get a plug in for shameless self-promotion for our IoT happy hour. Every Friday at 1600 UTC, we run an IoT happy hour hangout where we have some guests, or sometimes we do live builds. This project was featured on one of them a few weeks back, and you made the mistake of exposing what the URL for that buzzer is, and I see some regular viewers are in here watching today as well, and they very quickly bookmarked that URL to bother you from halfway around the world. So yeah, quick shout out. You can find it on our YouTube channel, youtube.com/BalenaIO. There's a playlist there that contains all of our past episodes for IoT Happy Hour. Then also, if you follow on Twitter, I typically will broadcast out in advance a link to each week's live stream. Topics vary. I see Matthew is given a watch right now as well. He was on last week. If you want to see some cool robot driving and 3D printing hacks, definitely go check out that episode. With that said, let me take a quick glance at chat for any questions that rolled in. I see Phil is asking why he doesn't have a Balena t-shirt. He clearly doesn't have the uniform. A few folks talking about ESP32s, which would certainly work. In this particular case, you know, using a Pi Zero is cheap also.
Yeah, that's there are obviously many ways you could do this.
Yep.
But this one does turn out to be really easy to deploy. I think that's what makes this one a nice project.
With that said, you would need a Pi Zero W in order to get some connectivity. Although, how would you connect on a Pi Zero without Wi-Fi? You'd have to use like a USB dongle of some type, I suppose, then.
Yeah, you would have to use, you know, it has that secondary port. I guess you would need to plug in a small hub and then a wireless dongle, a Wi-Fi dongle. But I think we mentioned that on the, you know, on that matrix that I referred to, how you can basically use any version of the Pi for this project, whatever you have available.
Awesome. Well, I'll put that link in one more time just for folks that joined late. So here's full documentation on the build. You can follow it along start to finish, either the industrial grade setup that Alan has there next to him, or the smaller breadboard version with some basic LEDs on it, and put in the GitHub repo for it as well, so folks can take a glance at that. With that said, I see we're coming up to the top of the hour. I apologize that we were a few minutes behind schedule due to a failure to click one button that says go live by myself. So apologies to the viewers for that. But I think we covered it all. Thank you, Alan, for taking the time and joining. Really appreciate it.
My pleasure. Thank you, David.
All right. Bye, everybody. See you later.
So long.